We can find physics in basically every aspect of everyday life, especially in sports. In sports, even though we don't often think about it, physics plays a key role in how actions play out. For example, track has many events, one being long jump. In long jump, the angle the athlete jumps from, the amount of force they use, and how fast they are running leading up to the jump can have a large impact on how far away they land. So how does the way you jump affect how far you land? This is the physics of long jump. Alright, so let's get into the science of all this. The projectile motion equation can be used to determine which angle will work best for the most distance out of your jump. This equation is d equals VO squared sine 2 theta divided by g, where d is the horizontal distance in meters, VO is the initial velocity in meters per second, g is gravity, which is a constant of negative 9.81 meters per second squared, and theta represents the angle of initial velocity from a horizontal plane. Now we are going to use the examples of 20 degrees, 45 degrees, 60 degrees, and 90 degrees to show how the angle affects how far the long jumper can go. For each equation, we will have the jumper's initial velocity be a constant at 6.67 meters per second, because that is the average running speed for long jump leading up to the actual jump. For the first example, we will use 20 degrees for the angle. Here is a drawing of what the track would be like with the athlete running to show a visual. When we plug in each variable into the projectile motion equation and solve, we end with their final distance being 2.91 meters, or 9.54 feet. Moving on to the second example, same setup. The only thing that changes is now we are using 45 degrees to solve. When you solve for this equation, the jumper's distance increases to 4.54 meters, or 14.9 feet. Now for the third example, we will use 60 degrees. Again, the same setup and variables, except this time the final distance decreases to 3.93 meters, or 12.9 feet. For our last example, we will use 90 degrees. Now, this should be obvious since 90 degrees is going straight up and down, but just to be 100% sure, I plugged it into the equation and, as expected, ended with 0 meters for the distance. Now, looking back, 45 degrees seems to be the best angle for jumpers to achieve the greatest distance. I even solved the equation for 44 degrees and 46 degrees to be certain, and 45 degrees was the best. Next, to use a real-world example, I looked up the world record long jump distances to test 45 degrees being the best angle. The men's world record is 29.4 feet. Using his initial velocity of 9.45 meters per second and solving at 45 degrees in the projectile motion equation, the result is 9.11 meters, which is 29.9 feet, very close to the number of the actual record of 29.4 feet. The women's world record in long jump is 24.7 feet. Using her initial velocity of 8.7 meters per second and solving for 45 degrees, the result is 7.72 meters, which is 25.3 feet. Again, very close to the actual record of 24.7 feet. This can be used as proof that the angle you jump at in long jump is important, and 45 degrees seems to be the best angle to result in the furthest distance. This is the physics of long jump.
Holy crap, Ryan. Ryan!
Filming her physics.